Taking a look at exercise number 13 in 12.3. So we're still looking at annuities due. We looked at future value and present value, and now we're going to look at calculating the interest, calculating the amount, the number of payments, and the amount of the payment. Your client has already accumulated $20,000 and plans to invest another $5,000 at the beginning of each year for the next 15 years. He expects to earn a return of 7.25% compounded annually on his investments. What size monthly payment can be withdrawn from the matured investment beginning in the 16th year if it continues to earn 4.5% compounded monthly for the next 15 years? These questions can be a bit overwhelming when you read them first, because you're like, how do I figure out the size of the monthly payment? But you got to take a step back and just kind of read through it again. What are we given? He currently has $20,000. He's going to invest another $5,000 at the beginning of every year for 15 years. He expects to earn 7.25% compounded annually on his investments. From that amount of money, after 15 years, he wants to buy an annuity that's going to pay, well, we don't know, but how much of an annuity can he buy that will pay him for the next 15 years? What size monthly? So monthly payments for the next 15 years, if that earns 4.5%. So it's two different things we're going to work out. So first we got to figure out, with these payments, how much money will he have after the 15 years? So $20,000 now, so that $20,000 is going to be invested, and it's going to earn the 7.25, so 7.25%. Plus, he's going to make payments of $5,000. So we're going to have a present value of $20,000. He's going to make payments of $5,000. It's at the beginning, so you're going to set your calculator to beginning. And it's going to do that for 15 years. And it's at the beginning of each year for 15 years. So that means the payments per year are annual, so it's 1. It's going to do it for 15 years, so N is going to be 15 years times 1 payment per year, so your N is going to be 15. The rate of return is going to be 7.25%. It's compounded annually, so your compounding per year is 1. So given that information, this is what we have into our calculator. It's set at beginning mode. 7.25 for your interest per year. Both your payment per year and your compounding per year are both 1. 15 years at 1 payment per year, so just 15 payments. He's going to invest the $20,000, and then he's going to make payments of $5,000 every year. So we're looking to figure out what will that money be worth at the end of that period. So it's going to be the future value, and he's going to have $194,524.43. Now, from that money, he wants to purchase an annuity that's going to give him monthly payments for the next, I think it's 15 years again. So you almost had to take it as two questions. It's asking, what's the future value of this amount? Then it's saying, given this X number of dollars, what monthly payment can you get at 4.5% compounded monthly for the next 15 years? Okay, it is 15. So it's like two questions in one. So it's going to earn 4.5%. It's a monthly payment he wants to get, and the compounding is also monthly. It's 15 years times 12 payments per year. So it's the number of payments is 180. And the amount we calculated here, that's the money he's going to use to purchase. So at that point in time, this becomes our present value, because this is what we have right now, and we want to purchase money that's going to come to us in the future. So this is the present value. There's not going to be nothing at the end. He's just going to be payments of whatever value. That's what we're looking for. So you set your future value at 0, and then you compute your payment. So basically what we're saying then is, if if he invests his $20,000 that he has right now, plus makes payments of $5,000 per year for the next 15 years at this interest rate and such, he'll end up with this amount of money. And then at the 15-year period, then when this is done, he can use that money to purchase monthly payments, an annuity that will pay him monthly payments every month for the next 15 years, and this is the size of the payment. So each of these separately, if that question had been broken out into two separate questions, you guys would have seen it many times before. But the fact that both of those questions were asked in one, you actually have to figure out that you have to do this first to calculate the future value, and then use that to determine the size of the payments.